Hello everyone, welcome back to my channel, Monica Math Classes. Today we are going to solve the third exercise of the topic Introduction to Trigonometry. It's a very important one because here you're going to involve a lot of algebraic identities and a lot of trigonometric identities, the three identities which you have learned. So let's get started. Uh, Initially, you will find a little problem of how to solve this, how do you know, but it will come eventually when you do a lot of practice on it. So these are the identities I have mentioned. So basically, these three algebraic identities, you have to remember it. And sometimes we have to use cubic identities as well. So I have placed this. You also make sure that you remember it. And then we have our three identities of, of in the last video, as I told you, in trigonometrical identities. So we are going to solve these as well. Okay, so make sure that you remember it by heart. I'm saying remember it by heart means you have to remember it. Otherwise, it's very difficult. You cannot proceed further in any question. Yeah, so let's begin. Now, in this question, if you see the first one, what they have asked you right now is express the trigonometric ratios sine A, sec A, and tan A in terms of cot A. Now they're very specific. They want all the answers in the form of cot A. Means you represent sine A as cot A, you represent sec A as cot A, you represent tan A as cot A. Yeah. So are we ready? Tan A and cot A is very easy. You know that cot A is reciprocal of tan A, so there is nothing. So it's not that difficult. But for sine A and sec A, you have to see it. So let's see it. So let's see the first question. I'm going to solve the first one. So how do you write sine A? So whatever you know for sine A, right now, you know that cosec A is the reciprocal of sine A. So at least you write like that. Because somewhere cosec and cot A are related. That's why I'm writing like this, because I cannot just go with sine A. So cosec and sine both are they are in reciprocal relationship. So write that part. And in this, a very important part, which I'm going to do right now, is that I am doing the square root of this cosec, as well as I'm doing the square and putting up the square root. Nothing happens, doesn't matter, because square and square root will cancel each other and you're left with cosec A. Okay, so this step is very important. Then we have, after this, do you remember the identity? So if you don't know right now, we can go back. So here, this one, cosec square. Okay, so this, sometimes they write like this. So this one is cosec square theta. So it is 1 plus cot square theta. So now in place of this, I can write as root 1 plus cot square theta or 1 plus cot square A, and that's my answer. That's it. How do I represent? This is the way to represent. So sine A can be represented in the form of cot A like this. So this is my answer. Now let's see for sec A. Now, again, for sec and cot, do you want to go back and check what is the relationship? Somewhere I'm making in this form, okay? So, because tan and cot can be easily irreplaceable. So, sec A, I can write like this, as a square root of this and as well as a square. Okay, so this step is used in many places. So you have to remember it. So square and square root. Now, sec square A, it is equal to 1 plus tan square theta, okay, or 1 plus tan square A. As I told you, it is easy to replace this tan in terms of cot, because you can write down this in reciprocal form. And then further, how to solve this, you have to take LCM of cot square A. So it becomes cot square A plus 1. And that's my answer, sec A. So how you represent second terms of cot A? This is the way to do it. Now next, you have tan A. Tan A is the easiest one. You know that both are in a reciprocal relation. So tan A can be written as 1 upon cot A. That's the answer. That's it. Then you don't have to do anything in it. I hope you are clear with this. Now let's move on to the second question. We will move little slowly in this. exercise because everything is new to understand in this. In each and every question is new. What trick I need to use it so that I can reach to that answer, or how do I prove my left side and right side? So let's see it. Second question is, write all the other trigonometric ratios. How many trigonometric ratios you know? 6. In terms of sec A. Now I have to write in terms of angle A, I have to write all of them. So let's get started. So sine A first. So sine A, I can write as sine A upon 1. Now, how does it help me? I don't see how to make it sec A. So the next step is I have to divide this by cos A. Now, what happened when I divide by cos A? By the way, there is a purpose for it that I have added sine A upon 1. You will see. So what happens? Sine A upon cos A. This becomes tan A, and 1 upon cos A is sec A. Is this my final answer? Not at all. What to do? Again, the same trick. Because still I have tan. So you have to make the root and make the square of it. Already in the denominator, you have sec A, so you don't need to do it. Now, there's an identity. How 1 plus tan square theta is sec square theta. So to make it sec square, tan square, you have to write down sec square A minus 1 upon sec A. And that is your answer. Easy? Yeah. Now, let's see for another trigonometric ratios, which is after sine A cos A. It is easy. You can just write down reciprocal part of it. Cos is sec. Okay. Now, after you have learned, the next part is your tan. I think you will understand better because we have done a little part of tan over here. So you will find that it's much easier now. So tan A, I'm making the root and the square of this, tan square A. As I told you, I can write as sec square A minus 1, and that is the only way to do it. So that's my answer. Now, after tan A, we have cot A. Now, cot A is the reciprocal of tan A. So whatever 10A you just got, you don't need to do it again. You just copy it and here we go. We got the answer. I told you, and in this you need a lot of practice as compared to the other exercises. I think it's done. Then we have question number 3. That's easy. So we will start with the question number 4. So here we have to prove left side, right side, and we have around 8 parts which we have to prove, and somehow all these 8 parts look different. So slowly and gradually we will try to solve each one of them so that you understand better. But I think this people get confident, and they get clarity when they solve certain type of questions again and again. So here you need a practice. So when I'm saying it, you need it. So let's start with the first part for this. So the first part is your cosec theta minus cot theta whole square. So here cosec theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. 1 minus cos theta upon 1 plus cos theta. So after this, I'm going to take the left side first. So left side is cosec theta minus cot theta whole square. So you have to simplify. So how can you write in terms of sine and cos? So cosec can be written as 1 upon sine theta minus cot theta. You can write as cos theta upon sine theta. I hope you remember that, because cot is reciprocal of tan. Yeah. And if it is sine upon cos, it becomes cos upon sine. I hope you have understood what I'm saying. So now here, how do you solve it further? You have to take this as LCM, sine theta. So what did you get inside? 1 minus cos theta whole square. Now you can rewrite as, separately as 1 minus cos theta whole square. You can write down like this also. There is no harm writing it. But what happened, as per my identity, sine square theta plus cos square theta is equal to 1. And from there, if I have to calculate sine square theta, it becomes 1 minus cos square theta. Okay. So that is what. So I am using the identity here. I'm writing for your reference so that you remember how did I reach to this part. So sine square theta plus cos square theta is equal to 1. So if I have to calculate sine square theta, it becomes 1 minus cos square theta. I hope you've understood. Now, this actually in the denominator, it takes the form of a square minus b square. Can you write like this? I'm writing for a square minus b square. I can. It is a minus b, a plus b. Do you remember when I told you that here you are going to use algebraic identities also? So you will use it a lot in many questions now. Now here you have in the denominator 1 minus cos theta, and up you have square. So this square can cancel. So you are left with 1 minus cos theta in the numerator and 1 plus cos theta in the denominator, and which is your right hand side, and hence proved. I hope you have understood. You can go back again and check how I have done, because I have taken each and every step of this. Now, let's see the second part of it. Question of this question 4, second part of it. What is the second part? The second part is cos A upon 1 plus sine A. And 1 plus sine A upon cos A is equal to 2 sec A. So let's write. So it is cos A first upon 1 plus sine A. Then you have plus sine 1 plus sine A upon cos A is equal to 2 sec A. I think you have to prove that. Okay, so I'm going to start with my left side. How do I start? I have to take LCM first. Okay, so LCM for this is 1 plus sine A and in the bracket cos A. Now, 1 plus sine A and 1 plus sine A, so you got cos square A in the numerator, and this becomes 1 plus sine A whole square. How do I solve it further? I have to use identity a plus b whole square in this. Okay, a square plus b square plus 2ab, which is 2 sine A, upon 1 plus sine A cos A. Now, you have to check that what you found in numerator. What did you get in numerator? Now you have cos square A. I'm circling it. I have sine square A. Now my identity of trigonometric identity, sine square theta plus cos square theta is equal to 1. So I can write them together. I can make it as 1. Let me write it together so that it's easy for you to understand. So I'm writing it together. Plus 1 plus 2 sine A upon 1 plus sine A and cos A. Now, let's move forward. So, now this particular part will become 1, 1 plus 1 plus 2 sine A upon 1 plus sine A cos A. 2 plus sine A now, in the numerator, you can take 2 as common. So what happened? You got 1 plus sine A in the numerator. And down you have 1 plus sine A, which is cos A. So you are left with 2 upon cos A. Now, how do you write this reciprocal? 1 upon cos A, which is sec A, 2 sec A. Isn't it? It is your right-hand side, and hence it's verified. I hope you've understood. Let's move on to the third part for this. So my third part, I have to go back and check this one. Tan theta upon 1 minus cot theta. Okay. So let's see how to solve this third part. It is tan theta upon 1 minus cot theta. Then you have plus cot theta upon 1 minus tan theta. Okay. And then 1 plus sec theta cos theta. Okay. 1 plus sec theta cosec theta, is it? Yes, sec theta cosec theta. Okay, so we have to begin with the left side. Okay. What we are going to do with this? So first, we will try to simplify this tan and cot in terms of sine and cos. Okay, so I can get more clarity here. So tan theta can be written as sine theta upon cos theta upon 1 minus cos theta upon sine theta. I hope you understand what I'm doing now. Plus here, this is cos theta upon sine theta, 1 minus sine theta upon cos theta. Now, how to solve it further? Obviously, in the numerator, you can't solve anything, so you have to write as it is. But in the denominator, if you see, you have sine theta as LCM, so you'll get sine theta minus cos theta. And similarly, on the other side of it, the other term will be written as it is. Here you have to take cos theta as the LCM. Okay, so here on this page only, I am solving further. So once I have solved this much, I have to simplify further. How do I simplify? You can do one thing. Sine theta upon cos theta divided by sine theta minus cos theta upon sine theta. What does it mean? That I can write the sine theta up because this is in the denominator. So if I have to change into multiplication, the denominator part will go up. So what happens after this? I'm writing here so that you understand what does it mean. So it means sine theta upon cos theta. And when I'm changing this division into multiplication, this sine theta will go up. Okay, so and sine theta minus cos theta will come. And similarly for the other side as well, plus cos theta upon sine theta into this cos theta will go up and you will left with cos theta minus sine theta. What happens? The next step is sine theta into sine theta. It becomes sine square theta upon cos theta, sine theta minus cos theta, and plus sine cos square theta upon sine theta and cos theta minus sine theta. Now, once you have solved this, you have solved a major part of for this one. You have solved around, 70% of it, I would say, because 30% of the proof is still left. How do I reach to 1 plus sec theta cos theta? This looks really far. Okay, so first you have, again, I'm repeating so that you understand. First, we are converting tan and cot as in terms of sine and cos. And then it is just simplification, simple simplification, denominator, taking LCM. And I reached to this part. Now, if you check in the denominator closely, I'm taking you to this. It is sine theta minus cos theta, and this is cos theta minus sine theta. See, the terms look same, but the difference of minus and plus. In the next step, when I want to take as a big LCM, I want sine theta minus cos theta as my LCM, along with sine theta and cos theta. How do I do that? Because in the other bracket, it is cos theta minus sin theta. There is a change in sign. So I'm going to change the sign outside of plus. I'll change it into minus. So this will give an impact. Okay, so look here. So what did I get? I'm writing here again. I got sine square theta. Okay, if I see sine square theta upon cos theta minus sin theta minus cos theta. Okay, so cos theta sine theta minus cos theta. And I told you that I want this as a complete one big. So I'm this plus sine, I'm changing into minus. This will make an impact. You look here. Cos square theta upon this one is sine theta cos theta minus. So when I'm making an impact, now what happened? So when I change it into minus, this automatically, whatever was minus, that will change into plus. So this will change into sine theta minus cos theta. So this is an impact. Now I want this complete LCM. So when I take this one complete LCM, this sine theta, sine theta minus cos theta. Okay. So what happens, you already have in the denominator cos theta and this, so you are left with only sine theta. So this becomes sine cube theta. And similarly, here it will become cos cube theta. You have reached to a stage where you have to use the identity, cubic identity, a cube minus b cube. Do you remember what is a cube minus b cube identity? If you remember, then you can use it fast. A cube minus b cube is a minus b, a square plus b square plus ab. Here you have to use this, otherwise it's difficult to solve it further. So my first is a minus b. So a minus b will be sine theta minus cos theta. And in the other bracket, it is sine square theta plus cos square theta and plus ab. So that is sine theta cos theta. I hope you have understood how we have used this. And down I have sine theta into cos theta and sine theta minus cos theta. If I see now in the numerator and denominator, this can be cancelled. Now, sine squared theta, this you can see as an identity. You can write in place of this as 1. So your numerator is now 1 plus sine theta cos theta. And down you have sine theta into cos theta. Now you have to separate. You have to separate all. So 1 upon sine theta cos theta plus sine theta cos theta upon sine theta cos theta. Okay, you can do that. Now 1 upon sine theta cos theta can be written as 1 upon sine theta means they're talking about cosec theta. And 1 upon cos, they're talking about sec theta. And this will cancel, you get 1. So in case you want to write it in order, so you can write 1 plus sec theta cosec theta. Do you want to see if it is your left side? You can check if it is your left side or not, if you have proved it or not. Yes, 1 plus sec theta cosec theta. You've reached to this stage. I know this takes a lot of steps and but with the practice only it will come. So don't worry. So here, again, you can go back and check the steps. Let's see for a moment. So you have to use your algebraic identities here, as well as you have to use your trigonometric identities in order to prove this. I hope all of you have understood today's class. In case you want to know anything again related to your trigonometry, you can write again in the comments, what do you want to know? But trigonometry, the third exercise especially, needs a lot of practice because each and every question is different. So I would say each one of you, by that time, rise and shine, Monica.